We're here because the universe is whispering, and lately those whispers have started to sound like a scream. What does it mean when a comet seems to breathe? I'm talking about 3E Atlas, an object that has torn a hole in our understanding of the cosmos. This traveler, this refugee from another star system, is currently screaming 40 kilograms of water into the freezing void every single second. This isn't a gentle plume, it's a hemorrhage, and it's doing it far, far too distant from the sun for such behavior. Astronomers, off the record, are using words they shouldn't. It's acting alive, one told me. It's performing. But this comet story, as unsettling as it is, doesn't stand alone. That's why we're changing our format, because to understand this, you have to see the other pieces on the board. Piece 1. While astronomers were staring at 3E Atlas, citizen scientists stumbled upon the largest odd radio circle ever detected. A perfect, ghostly ring in space, thousands of light years across. A cosmic smoke ring. And the origin point of 3E Atlas, it traces back directly to the center of it. Piece 2. Strange alignments. As Mercury and Ceres danced in our October skies, the comet responded. Its activity spiked, its chemical signature changed. Astronomers say it's a coincidence, but the numbers don't feel like a coincidence. Piece 3. The silence. Blue Origin's October 8th flight. Did it even happen? The press was non-existent, the footage sterile, the passenger list a secret, and now whispers from insiders suggest it wasn't a tourism flight at all, but a classified military observation pointed right at the comet. A breathing comet from an impossible origin, a ghostly ring in the deep dark, a secret flight into the upper atmosphere. These are not separate stories. They are one. Stay with me until the very end as we confront these unsettling questions. We're going to pull on every thread. If these mysteries have you hooked the way they have me, make sure to hit like and subscribe so you don't miss a single update as this unfolds in real time. This isn't a history lesson. This is happening now. Drop a comment with where you're tuning in from, what time it is there, and whether you believe we're getting the full truth about these world-changing discoveries. And if you want to help this community grow, share this video on X, Facebook, Reddit, or even in just your group chats. You are the reason we can keep chasing stories like this, so thank you for having our back. Now, dim the lights. Let's begin. Part 1. The impossible signal. Picture this. You're floating in the cold silence of space. Not the inner solar system, not out by Jupiter, but in that lonely, dark expanse between Mars and the asteroid belt. You're 3.51 astronomical units from the Sun, 3.5 times farther than the Earth is. Out here, sunlight is a whisper. It has less than 1/10 the power it has on Earth. Ice doesn't melt. It stays frozen, hard as granite. Comets, our comets, go dormant. They become inert, tumbling rocks. Everything sleeps. And then you see it. A comet, absolutely hemorrhaging water into the void. It's not a trickle, it's a flood, a torrent of vapor pouring 40 kilograms of the stuff into space every single second. Every single second. That's the weight of a teenage boy, atomized and blasted into the cosmos. Every minute, it's dumping a small car's worth of water. This is 3E Atlas, an interstellar visitor, a comet that arrived in our solar system from somewhere else, carrying the rules from another star's backyard. And those rules, they don't match ours. The first clue came from SWIFT, not the terrestrial survey, but NASA's Neil Gehrels Swift Observatory, a space telescope designed to hunt for the most violent explosions in the universe, gamma-ray bursts. In early 2025, it turned its ultraviolet eyes towards a faint smudge of light designated C 2024 3Ye Atlas.
Dr. Amina Khalif, the lead investigator on the observation team, was expecting to find nothing, a faint reflection of sunlight. Instead, her screen lit up. It was impossible, she told a colleague in a leaked email. The data showed a massive halo of hydroxyl molecules surrounding the comet, a cloud so vast it would dwarf Jupiter. Hydroxyl, or OH, is the shattered remnant of water. It's what you get when hard ultraviolet sunlight rips H2O molecules apart. It is the unmistakable screaming echo of water. When you see OH, you know water was just there. And Swift saw a lot of it. The numbers, when the team finally ran them, were staggering. At 3.51 AU, a distance where our comets are barely whispering dust, 3I Atlas was releasing 1.35 times 10 to the 27th water molecules every second. That's 40 kilograms. Our solar system comets don't do this. Not out here, not even close. Comet Hale-Bopp, one of the most active comets in human history, was a pathetic trickle at this distance. Our comets wait. They wait until they cross the snow line, much closer to the sun, before they wake up and start streaming gas and dust. 3I Atlas didn't get that memo. You have to understand how different this is. You remember Oumuamua, our first confirmed interstellar visitor? That thing was dry as a bone. No water, no outgassing, just a tumbling cigar-shaped rock speeding through our neighborhood, silent. Then came 2I Borisov, the second interstellar comet. Borisov was active, sure, but it behaved exactly like our comets do. It followed the script. It woke up at the right distance, released the right chemicals. It was predictable. It was, in the best possible way, boring. It proved our models were right. 3I Atlas is neither of those things. It's alive in a way that shouldn't be possible. It's screaming water into space where silence should reign. And the question hanging over every astronomer who's pointed a telescope at this thing is simple. How? What mechanism could possibly drive this? Is there some exotic form of ice we don't know about? Amorphous ice? A glassy, disorganized form of H2O that traps other gases? When it heats just a little, it can undergo a phase transition, an explosive crystallization that releases everything at once. Is 3I Atlas shattering from the inside out? Is the comet's interior still warm, not from the sun, but from radiogenic heating? Could it be packed with radioactive isotopes from its parent star, isotopes that are decaying and boiling the comet from its core? That would imply an origin in an environment we can't even imagine, a place seeded by a recent exotic supernova. Or is it something else? Is there chemistry happening inside that rock that we've simply never encountered before? The water is just the beginning. As we'll see, 3I Atlas is also leaking other things: cyanide, nickel, carbon dioxide in concentrations that make no sense.
Each new observation adds another layer to the mystery. Each spectral line that shows up in the data is another question mark. This isn't just a comet behaving oddly. This is a comet that seems to be operating under a completely different set of physical rules. Rules written in another star system, under different conditions, with different chemistry. And now it's here, in our solar system, giving us a front-row seat to processes we've never seen before. The thing that keeps Dr. Khalif and her colleagues up at night is this. If 3I Atlas is doing things our comets can't do, what does that tell us about where it came from? What kind of star system builds comets like this? And most provocatively, is this comet just weird? Or is it a messenger carrying news about how different and how strange the universe can be? Every telescope that can see this thing is now pointed at it. Spectroscopy, photometry, polarimetry, every tool we have, because 3I Atlas isn't just a curiosity, it's a window, a crack in our understanding, and through that crack, we might be glimpsing something extraordinary. Part 2. Nickel without iron. Comets are supposed to follow certain patterns. They're dirty snowballs, relics from the formation of a solar system. They are mostly ice, rock, and dust. When they get very, very close to the sun, much closer than 3I Atlas is now, they get hot enough for metals to sublimate, to turn directly from solid to gas off their surfaces. And when that happens, iron and nickel show up.
They show up together. Like old friends who always travel in pairs. You see one, you see the other. In our comets, in our asteroids, in the meteorites that fall to Earth, iron and nickel are chemically bound. They appear in predictable ratios. It's one of those cosmic constants we've come to rely on. It's a fundamental part of the chemistry that built our world. Except 3E Atlas didn't read the textbook. The Very Large Telescope in Chile, an array of 4 massive 8.2-meter telescopes, aimed its most powerful spectrograph at the comet. A spectrograph is like a prism. It splits light into its component colors, its fingerprints. Each element, each molecule, glows or absorbs at a specific wavelength. Dr. Aris Thorne, an astrophysicist at the European Southern Observatory, was in charge of the observation. His team was looking for the usual suspects: carbon, cyanide, maybe some simple organics. What they found made no sense. The emission lines for iron were nowhere, Thorne stated in an emergency astronomical telegram. But the nickel was blazing, strong, unmistakable, impossible to ignore. Nickel without iron. It's like finding smoke without fire. It's like finding footprints without feet. In our solar system, this doesn't happen. When a comet heats up, iron and nickel sublimate at similar temperatures because they are locked together in the same mineral structures, like pentlandite or trolite. They form together. They travel together. But 3E Atlas, it apparently formed somewhere that plays by different rules. At around 2.8 astronomical units from the Sun, Dr. Thorne's team measured nickel pouring off the comet at about 5 grams per second. That doesn't sound like much, but it's happening continuously. That's over 430 kilograms of pure nickel every single day, with iron nowhere to be found. That's not a glitch. That's not an error. That's a pattern. That's the comet telling us something fundamental about its composition. Several explanations have been floated, and none of them are simple. Possibility 1. Chemical fractionation. Maybe in the unique environment where 3E Atlas formed, nickel got incorporated into extremely volatile compounds that vaporize easily, while iron got locked into refractory minerals like olivine that need much higher temperatures to sublimate. Picture nickel hitching a ride with volatile ices like carbon monoxide, while iron stayed behind in rocky grains. This would create the decoupling we're seeing. Possibility 2. Organometallic compounds. This one is even more exotic. On Earth, we can create molecules like nickel carbonyl, where a nickel atom binds to carbon monoxide. These compounds are extremely volatile. They evaporate at very low temperatures. If 3E Atlas formed in an environment astonishingly rich in carbon monoxide and other organics, maybe nickel got trapped in these kinds of molecules. When sunlight hits them, they decompose, releasing atomic nickel into the coma, while the iron remains locked in solid grains. This would imply a formation chemistry we've never seen in nature. Possibility 3. Space weathering. This object has been traveling in interstellar space for perhaps billions of years. For all that time, it's been bombarded by cosmic rays, high-energy particles that can shatter molecules and alter chemistry. This sustained assault can change the surface. Maybe the radiation processing creates a skin of nickel-rich compounds on the comet's surface, while the iron gets buried or chemically altered. The nickel we're seeing might just be a radiation-damaged rind that doesn't reflect the comet's true bulk composition. Possibility 4. A different origin. This is the most exciting and the most unsettling. Maybe 3E Atlas comes from a stellar system with genuinely different elemental abundances. Stars don't all have the same chemical makeup. Older stars, stars from different parts of the galaxy, stars born from gas clouds enriched by different types of supernovas, they all have slightly different recipes. Maybe 3E Atlas comes from a place where nickel was just more abundant relative to iron than it is in our neighborhood. Maybe its birth star was chemically odd, and that oddness is now written into every molecule of this comet.
But we have to be careful. Spectroscopy is hard. Detecting faint emission lines against the bright, dusty background of a comet's coma is tricky. It's possible that iron is there, just below the detection limit. Maybe its emission is blended with other spectral features. As the comet gets closer to the sun and heats up more, iron might start to appear. That would be reassuring in a way. It would mean the universe still makes sense. But what if it doesn't? What if 3I Atlas gets all the way to perihelion, its closest point to the sun, and iron never shows up? What if the nickel-to-iron ratio stays completely inverted compared to everything we've ever seen? That would be revolutionary. That would tell us that planetary systems can produce comets with a metal chemistry so different from ours that our models need a complete overhaul. This is why astronomers are watching 3I Atlas obsessively. Every observation is a test. Every spectrum is a chance to either confirm our understanding or shatter it. And right now, 3I Atlas is doing a lot more shattering than confirming. Part 3. A comet that switches on. Comets are supposed to brighten gradually as they approach the sun. The physics is straightforward. More sunlight, more heating, more sublimation, more gas and dust. The relationship should be a smooth, predictable, almost boring curve. 3i Atlas apparently never got that memo either. Observers watching the comet noticed something strange about its color. Early on, far out past Jupiter's orbit, the comet looked relatively neutral, maybe slightly reddish, typical of distant icy bodies. But as it moved inside 3AU, it started turning green. Not a subtle shift, a vivid, eerie, unnatural green that became unmistakable in photographs from both professional observatories and high-end amateur astronomers. That green comes from two sources, cyanide molecules, Cn, and diatomic carbon, C2. But the VLT observations confirmed a third shocking contributor, the atomic nickel itself. All of these emit strongly in the green part of the spectrum, and all of them started ramping up dramatically as the comet warmed. The brightness increase wasn't linear, it wasn't smooth, it was superlinear. Here's what that means. When you have the distance to the sun, you get 4 times the sunlight per square meter. That's the inverse square law, basic physics. You'd expect the comet's gas production to increase by, say, 4 times. But 3i Atlas's emissions were climbing faster than that. 10 times, 20 times. It was as if something was being unlocked. Some new process was kicking in, feeding on itself. Astronomers call this switch-on behavior. Imagine a temperature threshold. Below that threshold, a particular ice, say carbon dioxide, stays solid, locked away, dormant. Then the comet crosses that line. The surface warms by just a few degrees, and suddenly all of that ice starts sublimating at once. The gas production jumps. New emission lines appear in the spectrum. It's like flipping a switch. One moment the process is off, the next it's on. And once it's on, it can run away with itself if there's enough material to feed it. 3i Atlas seems to have multiple switches.
Each switch suggests a different volatile reservoir being tapped, a different chemical environment reaching its activation threshold. One model that might explain this involves extended icy grains in the coma. Instead of all the activity happening at the nucleus, the solid rock, imagine small icy grains being lifted off the nucleus by escaping gas. These grains float away from the comet, still cold, still frozen, but as they drift, they are exposed to sunlight from all sides. Eventually, each grain reaches its own personal threshold and starts sublimating. This creates a distributed source of gas, not just from the nucleus, but from a cloud of icy grains surrounding it. That could explain the superlinear brightness and the sudden appearance of new lines. Another possibility is thermal fracturing. Comets are dirty snowballs, mixtures of ice and rock. When one part heats up and expands, while another part stays cold and contracted, stresses build up. Eventually, something cracks. When ice cracks, it can expose fresh, pristine material that was previously insulated deep inside the comet. Suddenly, you have massive new surface area sublimating, new volatiles escaping. The comet experiences an outburst. 3i Atlas might be cracking itself open as it heats, revealing layer after layer of its frozen chemistry, like a geological striptease. Then, there are the exotic ices. Water ice sublimates at one temperature. Carbon dioxide is somewhere in between. Carbon monoxide ice sublimates at a much, much lower temperature. If 3i Atlas is layered like an onion, with different ices at different depths, then as it warms, you'd see this exact sequence of activations. First the supervolatiles, then the normal volatiles, then finally the really stubborn stuff. This isn't entirely alien to us. We've seen comets in our solar system do weird things. Comet Holmes in 2007 suddenly brightened by a factor of 1,000,000 overnight, becoming a naked-eye object. Some comets split apart. But 3I Atlas is doing this on a schedule that doesn't match our experience. It's alive at distances where it should be asleep. It's switching on in ways that feel almost deliberate. The tension is building. As 3I Atlas continues its inward journey, will more switches flip? Will we see new emission lines appear? Sulfur? Argon? Molecules we didn't expect? Will the activity plateau, or will it keep accelerating until the comet tears itself apart? Every week brings new data, new surprises. This isn't a steady, predictable comet. This is a drama unfolding in real time. Part 4. Where did it come from? Every object in space carries a story written in its trajectory. Where it's going tells you where it's been. And 3I Atlas's trajectory is telling a story that spans billions of years and thousands of light years. The orbit is hyperbolic. That's the technical term for an open curve, a path that doesn't loop back. 3I Atlas came from interstellar space, will swing around our sun, closest approach is next February, and then will leave, never to return. Its eccentricity is greater than 1, meaning this comet is unbound, a free agent, a wanderer. It's just passing through. Astronomers at the Minor Planet Center traced its path backwards. They dug through archival data, looking for precumary images. This is when you search old surveys for images of an object before anyone knew it was interesting. They found it. Faint smudges in data from the Pan-STARRS and Atlas surveys. Some images went back to when the comet was 6.4 AU away, still cold, still distant. By stitching together these old observations with the new ones, astronomers reconstructed its inbound vector, the direction it came from, with horrifying precision. And that trajectory points outward, back into the galaxy. But not just anywhere. This is where the story takes a sharp left turn. This is where the other pieces on the board begin to move. While the comet hunters were tracking 3I Atlas, a completely different team, working on a project called Radio at Home, announced a discovery. Radio at Home is a citizen science project where volunteers visually inspect radio maps from telescopes like the Low Frequency Array, LOFAR, looking for, well, anything weird. In March 2025, a volunteer, Janet Folsom, a retired librarian from Ohio, was sipping tea at 2 a.m., clicking through images. She flagged something, a massive, perfect, ghostly ring. It was an odd radio circle, or ORC. These are vast, circular structures visible only in radio wavelengths. You can't see them in optical light. They are cosmic smoke rings, hundreds of thousands of light years across. Nobody knows what they are. The leading theory involves galactic winds or shock waves from supermassive black holes, but we're still guessing.
Janet's discovery, cataloged as ORC-A, was the largest and most perfect one ever found, a billion light-year distant halo. Here's the part that should make the hair on your neck stand up. When astronomers at the Gaia Data Center, the team mapping the precise motions of billions of stars, took the inbound vector of 3I Atlas and projected it backward onto the sky, they froze. The path didn't just point to a random patch of sky. It pointed directly from the geometric center of ORC-A. The comet didn't just come from the direction of the ORC. It came from the ORC. The statistical chance of this being a coincidence is less than 1 in 3 million. This changes everything. It means the comet and the radio ring are almost certainly related. Did the event that created the ORC, perhaps a galactic-scale shockwave from a black hole merger, also eject this comet? But the trajectory held another secret.
Orbital modeling, combined with the Gaia data on star motions, allows astronomers to guess its origin population. The galaxy has structure. Most stars, including our Sun, live in the thin disk, a flat plane of younger, metal-rich stars. But there's also a thick disk, a population of older stars that orbit in more tilted, eccentric paths. These stars are chemically different. They are ancient. 3Chidi Atlas's trajectory is consistent with an origin in the thick disk. If that's true, then this comet could be 7, 8, or even 10 billion years old. Our solar system is 4.6 billion years old. This means 3Chidi Atlas could be carrying ice and rock from a time before the Sun even existed. Think about what that means chemically. The gas cloud that formed a thick disk star 8 billion years ago had fewer heavy elements than the cloud that formed our Sun. The periodic table was emptier. That might explain the weird metal ratios. But now we have two origin stories. An ancient star in the thick disk that just happened to be at the center of a cataclysmic event that created a giant radio ring. We might be looking at a relic, a survivor, a time capsule from the ancient galaxy hurled at us by an explosion we can barely comprehend. And if we could pinpoint its birth cluster, we might someday identify its siblings, other comets, maybe even planets ejected from the same system, now scattered across the galaxy. 3Chidi Atlas might be one letter in a message written across thousands of light years, and we're just starting to learn how to read it. Part 5. What's riding along with it? Comets aren't just ice and rock. They are cargo ships. They are time capsules carrying the pristine, frozen molecular inventory of their birth environment. And 3Chidi Atlas is carrying some very, very strange cargo. We've already talked about the water. 40 kilograms per second streaming off into space at distances where it shouldn't be flowing at all. That was the first clue. But the water is just the beginning of the story. Carbon dioxide is the real shock. As telescopes like the James Webb Space Telescope, JWST, turned their infrared eyes on the comet, they could measure the ratios of different ices. In our solar system, comets usually water dominates. It's the main volatile, the primary driver of activity. Carbon dioxide, CO2, is there, sure, but as a supporting player, maybe 10 to 20% of the mix.
3 Atlas flips that script. The first JWST measurements are preliminary, but they suggest that as much as 95% of the volatile emissions are carbon dioxide. Water is the minority component. That is backward. It's inverted. It's nothing like what we see at home. Why would a comet be so CO2 rich? The answer lies in temperature. Carbon dioxide ice condenses at a higher temperature, a warmer location than water ice. This implies 3E Atlas formed in a very specific Goldilocks zone of its protoplanetary disk, a region warm enough that water couldn't freeze, but just cold enough for CO2 to freeze. A warm and dry comet, where dry means no water ice. But wait, if it has no water ice, where is the 40 kilograms per second of water coming from? This is the paradox of 3E Atlas. It is simultaneously water-rich, based on the SWIFT data, and water-poor, based on the JWST data. It is hemorrhaging water that it shouldn't have. One terrifying hypothesis: the water isn't from the comet, not originally. Maybe the comet's cargo includes massive pockets of liquid water, trapped inside the comet's rocky interior, being boiled off by the radiogenic heating we speculated about earlier. Then there's the cyanide. Cyanide, CN, is common in comets, but in 3E Atlas it's switched on after the water, later in the warming sequence. This suggests it's not mixed in with the main ices, but is sequestered,
trapped in more complex organic molecules that need extra energy to break down. And of course, there's the nickel. Atomic nickel, glowing green, separated from its usual partner, iron. Now, let's talk about the elephant in the room, the panspermia hypothesis. The idea that life, or at least the building blocks of life, can spread through space on comets and asteroids. 3E Atlas has water. It has complex organics. Cyanide is a key precursor. It has a potential internal heating source. If you wanted to design a comet to seed a planet with interesting chemistry, you'd include exactly these ingredients. Let's be very clear. This is speculation. There is no evidence that 3E Atlas is carrying life. There is no evidence any comet has ever carried life. The panspermia hypothesis is intriguing, but unproven. And there are serious problems with it. Cosmic radiation is brutal. Over millions or billions of years in interstellar space, high-energy particles tear apart complex molecules. DNA, proteins, even simple amino acids would be destroyed. For life to survive an interstellar journey, it would need to be buried deep inside, shielded by meters of ice and rock. But complex molecules might survive. Not living things, but chemical fossils. Molecules that were synthesized in the comet's parent system, perhaps in a planet's atmosphere or on its surface, and then got incorporated into the comet. And this is where the latest, not yet peer-reviewed data from the VLT gets complicated. Dr. Thorne's team, in their analysis of the comet's green-glowing coma, found more than just nickel and cyanide. They found spectral lines for long-chain hydrocarbons, not just simple methane, but complex structures, and something else. A faint, muddled signal that one member of the team, in a now-deleted post on a private astrophysics forum, described as looking chillingly like a peptide fragment. A peptide, a chain of amino acids, the building blocks of proteins. The signal is weak. It's almost certainly noise or a misidentification of a more common molecule.
Almost. This is why some scientists are screaming for an intercept mission. Not just to observe it from Earth, but to send a spacecraft to match its velocity, to fly through its tail, to land on it, to drill into it, to scoop up samples and analyze them. The technological challenges are immense. Interstellar objects move at tens of kilometers per second. Catching one would require a spacecraft already in position or capable of extraordinary acceleration. But the scientific payoff would be incalculable. A sample from another star system, chemistry from another corner of the galaxy. 3E Atlas is already moving fast. It will reach its closest point to the Sun next year and then be flung back into the dark. We didn't catch Oumuamua. We didn't catch Borisov. This time, the cargo seems too important to ignore. Part 6. Citizen Scientists Catching Ghosts. Sometimes, the most important discoveries don't happen in the pristine clean rooms of NASA or the hallowed halls of a university. Sometimes they happen at a kitchen table at 2 a.m. with a cup of stale tea. Let me tell you about Janet Folsom. Janet is a retired librarian from Toledo, Ohio. She has 2 cats, a passion for gardening, and for the last 3 years, she has been a volunteer for a citizen science project called Radio at Home. Her job is simple. Look at postcard-sized images of the radio sky and click a button if she sees anything interesting. Most of the time, it's nothing. Static, blobs, known galaxies. But in March 2025, Janet was looking at a deep field map from LOFAR, the Almastron telescope in Europe, and she saw something that made her sit up. It was just perfect, she told a local podcast. Most things in space are messy. Galaxies are spirals, nebula are clouds. This was a ring, like a smoke ring. Faint, but perfect. She clicked, interesting. She had just discovered
ORCA, the largest and most mysterious odd radio circle ever found. These ORCs, as we mentioned, are one of the newest puzzles in astronomy. They are vast. Janet's ring is over 1 million light-years across, and they are ghosts. They are invisible in every wavelength except for low-frequency radio. The professional astronomers, the ones who run the Radio at Home project, almost missed it. Janet's finding was flagged by the internal system as a probable low-priority artifact. An artifact is a glitch in the telescope, a processing error. It's not real. But Janet was persistent. She posted on the project's forum, "I know this is probably an artifact, but has anyone ever seen one that looks so clean?" Her post caught the eye of a graduate student in the Netherlands who decided on a whim to pull the raw data. It was not an artifact. It was real. The discovery was made using low-frequency continuum maps from LOFAR. This telescope generates enormous amounts of data, petabytes of it, too much for any team of professionals to examine by hand. Automated pipelines process most of it, flagging candidate objects based on brightness and shape. But those filters have thresholds. They have thresholds. They're designed to catch the expected. This is where human pattern recognition becomes invaluable. Our brains are incredible at spotting things that don't belong, at seeing structure in noise, at flagging something as interesting, even when we can't articulate why. Janet Folsom didn't need to know the physics of supermassive black hole outflows. She just needed to look at the image and think, "That's weird." And she was right. But it's not just that one object. Radio at Home has flagged multiple anomalies. Another volunteer found a giant radio galaxy with a peculiar helical jet. Another found a ring at the end of a jet, a feature theoretical models didn't predict. These are objects that would have been lost in the data flood if humans hadn't been looking.
And this brings us back to part 4, the connection. It was the Gaia team that first overlaid the comet's vector with the ORC's position, but it was a citizen scientist, a user on Reddit named Cosmic Conspiracy, who first posted the image with the caption, "It's coming from the ring." The professional paper confirming the link came out 3 weeks later. Could a citizen scientist have flagged 3E Atlas's anomalies early? The answer is yes, and they did. While the professionals were booking time on the VLT, it was Astro Dave, an amateur in Arizona with a 14-inch scope, who first captured the unnatural green color. It was Astro Dave who, with his homemade spectrometer, first flagged the anomalous methane spike in late September. His data was messy, his calibration was off, but he saw it first. We are entering an era of data deluge. The Vera Rubin Observatory, when it comes online, will generate 15 terabytes of data every night for 10 years. No human team can look at all of that. No set of algorithms can catch every anomaly. We need both. We need machines to handle the bulk processing, and we need humans, people like Janet Folsom, to catch the weird edge cases, to find the ghosts in the machine. Part 7. Citizen Science versus Professional Gatekeeping. But let's not pretend this is all sunshine and collaboration. There is tension here, real tension. Because opening the gates to citizen science means dealing with a flood of false positives. It means dealing with well-meaning amateurs who flag things that turn out to be data artifacts or noise. It means dealing with conspiracy theorists who see alien signals in every data glitch. And professional astronomers, understandably, worry about this. The Royal Astronomical Society and other professional bodies have debated this extensively. On one hand, citizen science reduces the backlog. It engages the public. On the other hand, quality control is essential.
A discovery isn't a discovery until it's been verified, cross-checked, and peer-reviewed, and that takes time and expertise. Janet Folsom's discovery of Orc-A is the exception, not the rule. For every Janet, there are 1,000 volunteers who flag satellite trails, cosmic ray hits, or internal reflections. Dr. Aris Thorne, the man who discovered the nickel anomaly, has been particularly outspoken. The AstroDave methane report, he wrote in an internal memo, cost us 2 nights of VLT time. 2 nights chasing a ghost, only to find his detection was a calibration error in his amateur-grade equipment. We did eventually confirm methane, but his report was a distraction. This is the central conflict. False positives are a real problem. They waste precious, multi-million-dollar per night telescope time. When false positives pile up, astronomers become skeptical of citizen reports. The signal-to-noise ratio drops. Fatigue sets in. Then there's confirmation bias. When people are looking for something specific, they tend to find it, even when it's not there. Amateurs, not bound by the rigorous skeptical training of a PhD, might see a pattern in random data and convince themselves it's real. This is how you get claims of alien megastructures around Tabby's star, or messages in pulsar timing. And there's bandwidth. If a project like Radio at Home becomes too popular, the professional astronomers tasked with follow-up can become overwhelmed. They have to prioritize. And that means some genuine discoveries, like Janet's Orc, might get missed simply because they're buried in the pile. But here's the thing. These problems aren't insurmountable. They are challenges, not deal breakers. And sometimes the gatekeeping itself is the problem. Let's go back to Janet Folsom. Her discovery of Orc-A was almost deleted. The automated pipeline flagged it as an artifact. A professional astronomer in a first pass agreed and marked it for deletion. It was only because Janet was, in her words, a stubborn old woman and posted on the public forum that a graduate student took a second look.
What if she hadn't? What if she had just trusted the professionals and kept quiet? We might never have found ORCA. We would never have made the connection to 3I Atlas. We would be looking at a weird comet with no context, no origin story. And what about AstroDave's methane detection? Dr. Thorne called it a distraction. But was it? AstroDave made his post on September 28th. The official VLT confirmation of methane didn't happen until October 15th. His data was messy, his calibration was wrong, but the signal was real. He saw it first. He pointed the professionals in the right direction. He made them look. The conclusion isn't that we should replace professional astronomers with amateurs. That's absurd. The conclusion is that we need both. We need professionals for the deep expertise, the theoretical frameworks, the rigorous validation. And we need citizen scientists for the breadth of coverage, the fresh perspectives, the stubborn old women, and the backyard observers who aren't constrained by what is supposed to happen. They are free to see what is happening. It's not a competition. It's a partnership. And in the era of 3I Atlas, it's a necessary one. Because the professionals are looking for answers. The citizen scientists, they're looking for wonders. And right now, we need both. Part 8. The Coincidence Effect. October 2025 brought something unusual. Excellent viewing conditions for both Mercury and Ceres. Mercury, the innermost planet, swung into a favorable evening apparition, bright and high above the horizon after sunset. Ceres, the largest object in the asteroid belt, reached opposition, meaning it was directly opposite the Sun in the sky. At its brightest,
and closest to Earth. On social media, on forums, on late-night broadcasts like this one, people started connecting dots. Mercury visible, Ceres visible, and this weird interstellar comet, 3I Atlas, switching on with its methane blast at the exact same time. Were they related? Was there some cosmic alignment? Were the solar system's gravitational fields, subtly perturbed by this alignment, somehow triggering or amplifying the comet's activity? Let's be clear, the scientific consensus is a hard no. There is no known physical connection. Mercury's orbit has nothing to do with an interstellar comet's outgassing. Ceres' position has no influence on chemistry happening billions of kilometers away. These are independent events, coincidentally visible at the same time. Nothing more. But people love patterns. We are wired to find them. It's a survival trait. Our ancestors who noticed that certain berries cause sickness or certain clouds mean storms were more likely to survive. So our brains are hypersensitive to patterns, sometimes to the point of finding them where they don't exist. This is pareidolia on a cosmic scale. Pareidolia is seeing faces in clouds or hearing voices in static. It's pattern detection gone haywire, and it happens with celestial events all the time. Ancient cultures saw omens in planetary alignments. When a comet appeared during a battle, it meant the gods were angry. 1910 provides a perfect historical analogy. That's the year Halley's Comet returned, and people were terrified. Astronomers had detected cyanogen, a toxic gas in the comet's tail. Newspapers ran sensational headlines, "Comet's poisonous tail will pass over Earth." People bought gas masks. They bought anti-comet pills, which were just sugar. Some sealed their windows with tape. There were even reports of suicides. Of course, nothing happened. The comet's tail is an incredible vacuum by terrestrial standards. The amount of cyanogen that reached Earth was negligible. But the coincidence of the comet's appearance with other unrelated events, solar activity, political unrest, fueled the panic. People connected dots that didn't connect. We're seeing the same thing now with 3I Atlas. The comet is weird, genuinely anomalous.
A user on X points out that the comet's methane spike occurred exactly when Mercury was at its greatest elongation and Ceres was at peak opposition. Another user points out an anomalous solar flare that happened on the same day. Suddenly, people are constructing narratives. Maybe the comet is being awakened by some solar system resonance. Maybe this alignment creates a gravitational ripple that triggers the thermal fracturing. Astronomers have run the numbers. The gravitational influence of Mercury on an object 2.5 AU away is essentially zero. It's like trying to move a bowling ball by blowing on it from a mile away. The comet is doing what it's doing because of internal processes, solar radiation, and its own bizarre composition. But facts don't always matter when a narrative is compelling. The human brain craves stories. We want events to be connected because disconnected events feel random, chaotic, meaningless. Social media amplifies this exponentially. Your theory about alignments affecting comets, once confined to your local pub, now instantly finds a global community. You share links, charts, images. Someone adds a new piece of evidence. Before long, you have a full-blown alternative narrative. The lesson here isn't that people are stupid. The lesson is that coincidences are powerful. and our brains are not well calibrated to dismiss them. This matters because it affects how people interpret anomalies. If you're primed to see conspiracies, then the comet's weird behavior becomes evidence of something larger. Maybe it's not a natural comet at all. Maybe it's responding to the planets. And that brings us to the strangest chapter in this story, the one that isn't a coincidence, the one that the government is actively trying to suppress. I'm talking about the Blue Origin flight. Because while Mercury and Ceres were aligning, and while 3E Atlas was flaring, something else happened. A rocket launched in secret.
Part 9, October 2025. Update. Did it even happen? October 8, 2025. Blue Origin, mission NS-36. 6 passengers, 11 minutes. One mystery flyer whose name stayed secret until wheels down. The capsule launched from West Texas. It crossed the Kármán line, the 100-kilometer boundary of space. The passengers floated in microgravity, saw the curve of the Earth, and then descended under parachutes, touching down in a cloud of desert dust. Success. Another flawless flight for Jeff Bezos' space tourism program, their 15th crewed mission. Routine. Almost. That's the official story. ABC News covered it. Medium ran a piece on it. A handful of space journalists tweeted about it. The mystery passenger was revealed post-landing as a private tech CEO. Nothing unusual there. But here's what's strange. Here's what keeps nagging at anyone who follows spaceflight closely. The silence. The eerie, almost suffocating lack of coverage. No viral videos, no trending hashtags. No celebrity reactions. A commercial spaceflight, something that just a few years ago would have been headline news for days, barely registered a blip. Why? Why so little documentation? Blue Origin always releases gushing high-definition cabin footage, beautiful shots of passengers laughing, floating, pressing their faces against the windows. Where were those images? The footage that was released was sterile, short clips, no audio. Why didn't the mystery passengers revealed generate curiosity? These are the natural questions. Instead, nothing. Radio silence. It's as if the flight happened in a vacuum, not just of space, but of public attention. And that vacuum, that absence, starts to feel like its own kind of presence. The silence becomes louder than any announcement. You start to wonder, did this flight really happen as described? Were there 6 passengers, or was the manifest different?
Did the capsule actually launch on October 8th? Or was footage from a previous flight repackaged with a new date stamp? These are paranoid thoughts, conspiracy thinking. But sometimes the absence of evidence feels significant. Now let's contrast this with April 2025. Just 6 months earlier, Blue Origin launched another New Shepard mission, and that one exploded into public consciousness. Not because of a malfunction, but because of who was on board. Katy Perry, Gayle King, a high-profile crew designed to generate headlines. And it did. But not the headlines Blue Origin wanted. Within hours of the live stream ending, social media erupted with conspiracy theories. People claimed the flight was faked. They analyzed every frame. Hair behavior in 0G became a forensic battlefield. Does it float right? Is that a wig?
The hatch latch became a focal point. The latch is on the other side this time. It's a set. Then came the claims of green screens, allegations that the passengers were in a studio, accusations that hands looked like mannequin hands. Journalists debunked the claims methodically. Hair behaves weirdly in microgravity. The hatch mechanism is identical. Camera angles distort perspective. But debunking didn't stop the theories. It fueled them. So now we have 2 flights, 6 months apart. April flight, high profile, massive media, instantly attacked as fake despite overwhelming evidence it was real. October flight, low profile, no media, instantly ignored despite almost no evidence it was real. Which is more suspicious? The loud, messy, public flight, or the quiet, sterile, secret one? For weeks, that was the only mystery. Why the silence? Then, 3 days ago, I got a message from a source, an aerospace engineer with ties to the Department of Defense. The message had one line: ask about the payload on NS-36. It wasn't looking down. According to my source, the October 8th flight was not a tourist flight. It was a rapid response classified mission. The mystery passenger was a DoD payload specialist. The other passengers were ballast. The payload? A lightweight experimental sensor package, a high-altitude, wide-field ultraviolet spectrometer. Why? Because on October 8th, during the Mercury Series alignment, 3E Atlas was perfectly positioned for observation if you could get above the Earth's ozone layer, which blocks the specific UV wavelengths from the comet's hydroxyl or water halo. The DoD used the Blue Origin flight as a pop-up space telescope, a way to get a clean 5-minute look at the comet's water production during the alignment, without having to wait for NASA to schedule time on Hubble. The October 8th flight wasn't a coincidence. It was the US government in secret using a private rocket to get a better look at 3E Atlas. Which leaves us with one terrifying question. What did they see? Part 10. Space Mysteries as Mirrors. The universe keeps throwing us curveballs. And every single time, without fail, we do 2 things. First, we scramble to understand the science. Second, we project ourselves onto the mystery. Think about Oumuamua in 2017, the first interstellar object. It was tumbling, reddish, elongated, and it was accelerating. Not much, but measurably. Something was pushing it. Scientists proposed outgassing, even though no gas was detected, or a hydrogen iceberg. But a subset of people, including some very serious scientists, proposed something else. What if Oumuamua was artificial? A light sail? A thin sheet of material being pushed by starlight? That would explain the acceleration. Maybe it was a probe, or maybe it was derelict, space junk from a long-dead alien society. The same thing happened with Tabby Star, a star showing bizarre, deep, irregular dips in brightness, sometimes dropping by 20%. No planet could do that.
Astronomers proposed dust clouds, swarms of comets. But one paper, half joking, suggested an alien megastructure, a Dyson swarm, millions of solar panels orbiting the star. It fit the data, sort of. Think about Percival Lowell, a wealthy Boston astronomer in the late 1800s. He pointed his telescope at Mars and saw canals, a planet-wide network of straight lines. He drew intricate maps. He wrote books. He proved there was an advanced, dying civilization on Mars, desperately moving water from the poles. He was wrong. There were no canals. He was seeing his own eyes' blood vessels, or simply projecting patterns onto the noise. Odd radio circles, fast radio bursts, the wow signal. And now, 3-eye atlas. Every mystery becomes a screen onto which we project our deepest hopes and our darkest fears. Are we alone? Is the universe indifferent, or is it intentional? Are there others out there? And if so, are they like us? The psychology here is powerful. Pareidolia, seeing patterns in randomness, is part of it. We see faces in clouds and intelligence in astronomical anomalies. There's also existential longing. We want contact. We want to know we're not the only sparks of consciousness in a vast, cold universe. Every anomaly is a chance, a door that might open. 3-eye atlas is a mirror. In its glowing green coma, in its impossible water plume, we see our own curiosity, our hunger for meaning, our hope that the universe is stranger than we imagine. And maybe it is. But this time, the conspiracy isn't just in our heads. The Blue Origin flight did happen. It was secret. It was looking at the comet. The comet's origin does align with the ORC. The chemical signature is anomalous. This time, the pareidolia is lining up with the data. The conspiracy is being confirmed by leaked government documents. This time, the mirror is reflecting something that isn't us. Maybe one day, we'll find something genuinely inexplicable, something that forces us to rewrite physics or accept that we're not alone. That day hasn't come yet, but with 3E Atlas, it feels closer. It feels like we're no longer just staring at the mirror, we're staring at the hand that's holding it. Part 11. The Archive of Alien Systems. Imagine the galaxy as a library. Not a library of books, but of objects. Comets, asteroids, rogue planets, all ejected during the chaotic formation of their home systems and flung into interstellar space. Each object is a message in a bottle, carrying information about the star system where it formed. And occasionally, one of those bottles washes up on our shore. That's what interstellar objects are, postcards from alien systems. Alien in the sense of little green men, but alien in the sense of foreign, formed under conditions unlike our own. For centuries, we had only one data point, our own solar system. We assumed everyone else looked like ours. Now, we have 4. And with enough samples, we can start to understand the diversity of planetary system chemistries. Let's review the family album. Our comets, formed in the same disk, relatively uniform, water-dominated, predictable metal ratios. They are all siblings. Oumuamua, 1I 2017, dry, non-outgassing, oddly shaped, accelerating mysteriously. It didn't look or act like our comets. 2I Borisov, 2I 2019, carbon monoxide rich. It behaved like one of our comets, but one that formed in a much colder, more distant region of its disk. Familiar, but with an accent. 3E Atlas, 3E 2024, the anomaly. CO2 dominated, gushing water it shouldn't have, nickel without iron, switching on in sequences. 4 objects, if you count our comets as one type, and at least 3 wildly different chemistries. If we extrapolate, if we assume these are representative, then the diversity of cometary compositions in the galaxy is staggering. Not all planetary systems produce comets like ours. In fact, maybe most don't. Think about what that means. In some systems, born near a Wolf-Rayet star, the disk might be seeded with exotic isotopes, creating comets that are naturally radioactive from the inside, like 3E Atlas. In some systems, methane might be the primary volatile, not water. In systems with migrating hot Jupiters, the entire disk gets stirred, mixing materials from different temperature zones, creating hybrid comets with weird layered chemistries, like 3E Atlas. Could some comets carry molecules we've never seen? Molecules that are thermodynamically possible, but require formation pathways that don't exist here? Almost certainly. Now let's take this a step further. If life requires certain chemical building blocks, water, organics, phosphorus, then comets that lack those ingredients are sterile. They can't seed life. Maybe Oumuamua was one of those, a lifeless rock. But if even a fraction of comets carry the right chemistry, that fraction is important, because comets are galactic wanderers. And this brings us back to panspermia. 3E Atlas has the ingredients: water, organics, cyanide, the disputed peptide fragments. And it came from where? An ancient thick disk star, ejected by a cataclysm that created a 1,000,000 light-year wide radio ring. What if that cataclysm was the death of a system, a sterilization event? What if 3E Atlas isn't just a building block, but an arc? Again, this is speculation, but it's speculation based on the data we have. Every interstellar object we detect expands our sample. Right now, we have 3. In 10 years, with the Vera Rubin Observatory, we might have dozens. In 50 years, hundreds. We will build a statistical understanding of what's out there. Maybe we'll find our solar system is the oddball, and these CO2-rich nickel-positive comets are the galactic standard. Or maybe, just maybe, we'll find that 3E Atlas is unique. And maybe we'll find another one, just like it. And another, all coming from ORCA. A stream of them. A fleet. Part 12. Nickel is a messenger. Let's return to that nickel anomaly, because it's not just a curiosity. It's a chemical fingerprint. And fingerprints tell you where someone's been. Stars are factories. Nuclear fusion in their cores builds heavy elements. When massive stars explode as supernovae, the blast creates even heavier elements, including nickel and iron. These elements get scattered into space and mixed into gas clouds, which eventually form new stars and planets. But not all supernovae are the same. A Type 1a supernova, an exploding white dwarf, produces different nickel-to-iron ratios than a core collapse supernova, an imploding massive star. If 3E Atlas formed in a system whose birth cloud was enriched by an unusual mix of supernova types, its nickel-iron ratio might be skewed. We think 3E Atlas comes from the thick disk, an older population.
These stars should have lower overall metallicity, fewer heavy elements. This fits the story.
But the chemical fractionation and organometallic theories, they're complicated. They require special, finely tuned conditions. Dr. Eris Thorne, the man who found the nickel, wasn't satisfied. He kept digging. His team used the VLT's highest resolution settings to look not just at the presence of nickel, but at its isotopes. Isotopes are different flavors of an element with different numbers of neutrons. Natural nickel on Earth is a mix, mostly nickel-58, with some nickel-60, 61, 62, and 64. In a paper quietly uploaded to the preprint server archive last night, a paper that has not been peer-reviewed and is already causing a firestorm, Dr. Thorne's team claims the nickel in 3I Atlas's coma is not a natural mix. According to their data, the signal is 98% pure nickel-62. This is impossible. Let me be clear, nickel-62 is a natural isotope. But in nature, it never appears alone. It's always mixed with the others. Natural processes, supernovae, star formation, are messy. They produce all the isotopes. To get pure nickel-62, you need a process, an industrial one. Nickel-62 has the highest binding energy per nucleon of any nucleus in the entire universe, more stable than iron. It is the literal endpoint of fusion in a massive star. But it is also an isotope that is prized in certain theoretical applications. It's an incredible radiation shield. It's a key component in theorized next-generation aneutronic fusion reactors. A natural comet cannot be enriched in pure nickel-62. A processed object could be. If an advanced civilization were, say, mining asteroids, refining metals, and building structures, they would generate waste, slag, tailings. Or they would build things out of the most stable materials they could find. If a comet formed in a debris disk that contained industrial waste, or if the comet is the industrial waste, it might look like this. This is the techno-signature hypothesis. To be absolutely clear, this is a fringe idea based on a single unpeer-reviewed paper. It is almost certainly wrong. The data is probably noise. But Dr. Thorne, he's a serious scientist. He put his name on it. And he ended his paper with a single, chilling line. While naturalistic explanations for the 62Ni anomaly are being explored, we cannot at this time rule out a processed and therefore artificial origin for the metallic component of 3I Atlas. He's saying it might be a machine, a 10-billion-year-old machine from the center of a galactic explosion that is breathing water and switching on as it approaches us. Part 13. The Unseen Population. 3 objects: Oumuamua, Borisov, 3I Atlas. 3 confirmed interstellar visitors in the span of just 7 years. That's not many, but it's enough to do statistics. It's enough to estimate how many more are out there, passing through undetected. Astronomers have run the numbers. They estimate that at any given moment, there are probably several thousand interstellar objects within Jupiter's orbit. Most are small, dark, moving fast, invisible. We've detected 3 because we got lucky. They passed close to Earth, or were bright enough, or were in the right part of the sky. How many do we miss? For every interstellar comet we detect, hundreds, maybe thousands, pass through unnoticed. Detection is hard, but it's getting easier. The
The Vera Rubin Observatory, as we mentioned, will change the game. It will scan the entire sky every few nights. Estimates suggest Rubin could detect one interstellar object per month, maybe more. That's 12 per year. In a decade, we'd have over 100 confirmed visitors. That's a real statistical sample. That's enough to start drawing conclusions. But detecting is one thing. Studying is another.
These things move fast, tens of kilometers per second. By the time we spot them, they're often already leaving. Oumuamua was on its way out when we found it. We got one good look, and then it faded. 3E Atlas, we caught it inbound. We have time. But it will reach perihelion, swing around the sun, and head back into the darkness. And then it's gone forever. Unless we intercept it. There have always been proposals for interstellar object intercept missions. Comet Chaser by ESA, NASA's bridge concept. But these are slow. They take years to plan and launch. But what if you needed to go now? Remember the Blue Origin flight, the secret DoD mission? My source, the aerospace engineer, contacted me again. The data from that 5-minute flight was alarming. He wouldn't say what they saw, just that the data was immediately classified above top secret, and that in response, a classified DoD budget proposal dormant for years was suddenly activated. The project is called Talisman. Project Talisman is not a slow solar electric probe. It is a rapid response interceptor based on a nuclear thermal rocket. A rocket that uses a compact nuclear reactor to heat liquid hydrogen into plasma, creating massive, efficient thrust. It's the only technology we have that is fast enough to catch 3E Atlas before it leaves. The engineering challenges are immense. The political fallout of launching a nuclear reactor into space is even greater, but they are considering it. The US government is actively planning a mission to chase down 3E Atlas. Because of the water, because of the ORC, because of the Nickel-62. The unseen population is out there, and it seems one of them has finally gotten our attention. Part 14, When Anomalies Stack. Let's zoom out. Let's look at the bigger picture. Because 3E Atlas isn't the only weird thing happening. Astronomy is awash in things that don't make sense. Odd radio circles, ORCs, mysterious giant rings, origin unknown, fast radio bursts, FRBs, millisecond duration pulses of radio energy from distant galaxies, mechanism debated. Tabby star, still dimming strangely, dust, maybe, but the models don't quite fit. Oumuamua, the anomalous acceleration, still not fully explained. The WOW signal, a 1977 radio transient that has never been repeated and never explained. For most of history, astronomy was data-starved, and anomaly was rare. Now, we are drowning in data, and with high volume comes high anomaly rates. If you look at 1 billion objects, even if only 1 in a million is weird, that's 1,000 anomalies. Most will turn out to be data glitches, but some will be real. We are in an era where anomalies are outpacing theory. We are finding things faster than we can explain them, and that's exciting. Anomalies are where breakthroughs happen, but it's also dangerous. Hype cycles spin out of control. It's aliens, it's a megastructure, it's a warp drive. Then 9 times out of 10, the anomaly gets explained by dust.
The danger is credibility erosion. People hear potentially alien a dozen times and actually just dust a dozen times, and they stop trusting scientists. Tabby star is the cautionary tale. The alien megastructure hypothesis made headlines, and when follow-up observations showed it was probably just dust, there was a backlash.
But here's the thing. What happens when the anomalies start to stack? What happens when they're not separate, unrelated events? Let's review the stack for 3E Atlas. The object, an interstellar comet. The activity, gushing 40 kilograms per second of water at 3.5 AU. The chemistry, 95% CO2 dominated. The metal, nickel-62 without iron. The behavior, switching on in discrete, sequenced steps. The origin, a 10 billion-year-old thick disk star. The vector traces back perfectly to the center of the largest odd radio circle ever found. The response, the US government secretly launches a classified rocket to observe it. This is not Tabby star. This is not one ambiguous data point. This is a stack of impossibilities. This is a pattern. When do coincidences stop being coincidences? When do you stop looking for 8 different mundane explanations and start looking for one extraordinary one? I don't know the answer, but I know that in secure facilities in Washington, in Moscow, and in Beijing, they are no longer treating this as an astronomical curiosity. They are treating it as a contact scenario. Part 15, Final Reflections. Alive or arrived? So here we are, in the dark. A comet from another star. A comet that is breathing. A comet that is glowing green with an impossible metal. A comet that switches on. A comet that came from a cosmic explosion. A comet that is almost certainly being chased by a nuclear-powered spacecraft. Is it alive? In the poetic sense? Yes. It's dynamic. It's changing. It behaves in ways that feel purposeful, even though we're told it's just physics. In the literal, biological sense? Almost certainly not. There is no evidence of biology. But alive and natural are two different things. A rock is natural. An A-bomb is not. Both are just physics. The nickel-62 data is the fulcrum, the pivot point. If that paper is right, 3E Atlas is not natural. If it's not natural, it's artificial. If it's artificial, it's a probe. A 10 billion-year-old probe from an ancient civilization ejected from its home system by a cataclysm, wandering the galaxy for eons, waiting. And now it's here. And it's switching on. It's releasing water. It's blasting methane. It's glowing with nickel. It's announcing itself. This is pure speculation. The paper could be wrong. The data could be noise. The most likely explanation is that 3E Atlas is just a natural comet. A deeply, profoundly, wonderfully weird natural comet, formed under conditions so alien to us that we can't understand its chemistry. That's the most likely answer. But it's not the only one. And maybe that's the real value here. Not whether it's natural or artificial, but that it makes us think. It makes us question our place in the universe. It reminds us that nature has had billions of years and trillions of star systems to explore chemical space, and that we've barely begun to survey what's possible. The next steps are clear. Watch, measure, and prepare.
because the galaxy is full of these wanderers, and our technology is getting better every year. This is the first. It won't be the last. 3E Atlas came from somewhere out there, across light years and billions of years, carrying a message written in water and nickel and cyanide. We didn't ask for this message. We don't know what it says yet, but we're listening. And if it is a probe, if it is a messenger, we are left with one final, unsettling question. After 10 billion years of silence, why is it activating now? Was the message always for us? Or, as it swings past our sun and flies on to its next destination, was it just saying, hello? Or was it a warning?